Hi, this is Mary Sindhuja, working as an associate professor in the Department of Electronics and Communication Engineering at Comrade College of Engineering. In this lecture, I am going to explain about how to simulate inverting as well as non-inverting operational amplifiers using PSIM software. This is the outline of my presentation. So, first, what is PSIM? It is a power simulator which is used to simulate electronic circuit, and it is also a design software which is specially made for power electronics, motor drives, power conversion systems. It provides very fast simulation speed, and it is user friendly interface. The PSIM is also provides a powerful environment to meet the simulation as well as the design needs. So, these are the modules present in PSIM. The advantages of PSIM software is, because for circuit simulation we will be normally using multisim, PSPICE. So, apart from these softwares, the PSIM has the advantages such as any circuit we can easily create using the PSIM software. So, to handle large systems, the PSIM will provide sub-circuit function which is used to divide the large circuit into sub-circuits, so that the easy simulation can be achieved by using the sub-circuit block. The PSIM is an ideal for system level simulation. The Bode plot as well as Nyquist plot, which is used to determine the stability of a system, which gives the stability in terms of gain as well as phase margin, can be done by using this PSIM software. So, for the circuit designed, code can be generated, C code can be generated. So, easy interface with PowerSim, Simulink, DSP processors as well as with JMAC. So, in the RF, apart from analyzing the RF characteristics of the circuit, the PSIM will provide the frequency response of any RF circuits. So, here I will explain a design procedure of inverting as well as non-inverting operational amplifier. So, with the design procedure, the same circuit I will show it as a simulation in PSIM software. So, in the inverting operational amplifier, we know that we are asked to design the inverting operational amplifier with the gain 2. So, the gain of inverting operational amplifier AV is equal to minus RF by R1. So, we need to assume the input resistance R1 is equal to 10 kilo ohm, and by using the gain equation we will get the feedback resistance RF is equal to 20 kilo ohm. So, once R1 as well as RF is calculated, we can substitute in the circuit as 20 kilo ohm as well as R1 is equal to 10 kilo ohm. When the input given to the inverting operational amplifier is of 1 volt, this is the input voltage, and here it is time. Since it is an inverting operational amplifier and the gain of the inverting operational amplifier is 2, so the output voltage will be equal to 2 volt, as well as the output will be the inversion of input. It will be inverted, the phase difference will be around 180 degree between the input as well as output. So, we will see the design procedure of non-inverting operational amplifier with gain 3. So, for a non-inverting operational amplifier, AV is equal to 1 plus RF by R1. So, by assuming R1 is equal to 10 kilo ohm, using the gain equation, we can obtain the feedback resistance RF. So 1 plus RF by R1 is equal to 3. So RF by R1 is equal to 2. So we have assumed R1 is equal to 10 kilo ohm. So RF is again 20 kilo ohm. So we can substitute the values in the circuit. So since it is an non-inverting operational amplifier, the phase shift between the input as well as output will be 0 degree. So we consider the input signal of amplitude 1 volt the output, it does not provide any phase shift. Since the gain is 3, the amplification will be 3 volt. So we will get the output signal amplitude as 3 volt. This is the PSIM software. So here we have in the library number of elements that we can select from this library, and we can connect all those components by using the wire connection which is present here, and we can do the simulation process. So first we will see how we can simulate an inverting operational amplifier using the PSIM. So first go to the elements, under power, in the option other, select operational amplifier level 1 and place it here. After that we need to connect the resistors, input resistor as well as the feedback resistor. So again go to power, and here we have resistor. So place it in the feedback end as well as in the input end of the operational amplifier. Next we need to connect the sources. So go to elements, there we have an option sources. So there we need to give sine input. So you select sine and place it here. Next we need to select the ground. So go to elements, select the sources, there you have an option of ground. So we need to place 2 grounds at the inverting as well as non-inverting terminal of the operational amplifier. So once the components are placed, we can change the value of the resistance. First we are going to design inverting operational amplifier. So the feedback resistance is 20K. Select the display option. So this resistor value is changed to 20K. So at the input, this is the feedback resistance. So we will name it as RF. And this is the input resistance. So we will name it as R1. The input resistance is of 10K. For the inverting operational amplifier with the gain 2, the input resistance is 10 kilo ohm, and the input we are going to consider, we will name it as V in, frequency as 2 kilohertz, amplitude as 1 volt. So if we enable all these things, it will be displayed in the element. After this, using wire option, we need to connect all these components. So non-inverting terminal is grounded since it is an inverting operational amplifier. After this, we need to place probe at the input as well as output in order to display the input voltage as well as output voltage. So for that, again go to elements, go to sources, go to other. Here we have the option of probes. Select the voltage probe because we are going to display the input as well as output voltages. So you place the voltage probe at input as well as output. So after placing the probe, we need to, and this probe is V out, place a simulation control. After that, run the simulation and so we have given the peak to peak input voltage is 2. Since the gain of the inverting operational amplifier is 2, so the output peak to peak amplitude should be also 4 volt. So here you can change the frequency and run the circuit again. 1 kilohertz. So you can infer the change in frequency also. In the same way, we can design the non-inverting operational amplifier with the gain 3. For that, we need to place the input to the non-inverting terminal. Inverting terminal need to be grounded. We need to place the input probe at the non-inverting terminal of the operational amplifier. So since the gain of this non-inverting operational amplifier is 3, the RF is equal to, feedback resistance is 20 kilo ohm and input resistance is 10 kilo ohm. So we will run the simulation. So we need to add the input as well as output voltages. Here again the input peak to peak voltage is 2. Since the gain is 3, the output need to be 6 volt. So this blue color wave represents the output voltage. So the peak to peak amplitude of this wave is 6 volt. So we have designed a non-inverting operational amplifier with a gain 3. So in the same way, we can design the voltage follower circuit also by removing the feedback resistance as well as the input resistance. Remove the ground. Run the simulation, add input as well as output voltage. So whatever input voltage is given, the same output will be produced at the output of the voltage follower. Since the gain of the voltage follower is equal to 1, the output follows the input. Thank you. Have a nice day.